Bright Tuty. Every student matters.
Hello children, welcome to the session. In this session, we are about to discuss few naturally occurring indicators, and in the previous session we have discussed that what are indicators, and indicators are the substances which indicates the which indicates whether a substance is acidic or basic in nature. So the first natural indicator that we are about to study is litmus. Yes children, litmus is obtained from plant. You can observe it from this image lichens, and from this we obtain litmus solution, and this litmus solution has a mauve color in distilled water, and we use this solution as an indicator. And how do we use it? Suppose we have to test this solution A whether it is acidic or basic. What we will do, we will add few drops of this indicator solution to this, and the color change will indicate whether A is acidic or basic. Okay, and also nowadays litmus is available in the form of paper. You can observe it, red litmus paper and blue litmus paper. So not only solution, we have litmus papers as well. Okay, now we will discuss about the color changes which indicates whether a substance is acidic or basic. Okay. Now suppose we have to test this solution. This is acid and we have this other beaker, say B, and this is basic in nature. This is acidic A and this is basic B. And if we add red litmus to acid, it will remain red only. There will be, you will see that there is no change in color. But if you add blue litmus paper or a few drops of blue litmus solution to acid, it will change into red color. Okay children, so in acids, red litmus remains red in color, but if we add blue litmus, it will be converted to red color. So this is the color change that you observe in case of acids. Now we will discuss about the color change in bases. In bases, if we add red litmus, it will be converted into blue in color. Whereas if we add blue litmus paper or we add a few drops of blue litmus solution, it will be there will be no change in color and it will remain blue only. Okay. So this is the color change that you will observe when you add red or blue litmus solution or red and blue litmus paper to the acid and basic solutions. Okay.
To find the effect on different solutions. On red litmus paper and blue litmus. Materials required: common salt solution, soap solution, baking soda solution, hydrochloric acid solution, washing soda solution, aerated water, shampoo solution, lime juice solution, nitric acid solution, lime water, vinegar, red litmus paper, blue litmus paper, dropper, distilled water. Method: mix a few drops of vinegar in the beaker, half filled with distilled water. Take a dropper and fill it with the solution of vinegar. Pour a drop of the solution on 1. Blue litmus paper, 2. Red litmus paper. You observe that the blue litmus paper turns red, but there is no effect on the red litmus paper. Conclusion: thus, vinegar solution is acidic in nature. Repeat the procedure with each in the soap solution, aerated water, common salt solution, shampoo solution, baking soda solution, lemon juice solution, hydrochloric acid solution, nitric acid solution, washing soda solution and lime water.
make a table like this. For example, we have done the test with lemon juice solution and effect on red paper. There will be no effect on the red litmus paper, but on blue litmus paper it will be converted to, it will be changed to red color. Okay, and what is the inference drawn from this? It means that lemon juice is acidic in nature. That is why it has converted blue litmus to red in color, and there was no effect on red litmus paper. Okay. Similarly, you will conduct this activity for various other solutions. Say you can take sodium hydroxide, or you can test as many solutions or substances as you can and figure out whether a substance is acidic or basic in nature. So let us now move ahead. Before moving further, children, you should know that you can come across certain substances which does not change the color of either red or blue litmus paper. There will be substances which will not convert any of this paper. So such substances will be known as neutral solutions. Why? Because they are neither acidic nor they are basic. Okay, and that is why we call them as neutral solutions. Okay, so let us now move ahead, and we have our next indicator. Next natural indicator is turmeric, and this is commonly known as haldi, and it is used in cooking food, and this is a natural indicator, children. For this you will again conduct an activity. You will take a tablespoon full of turmeric powder. You will add little water to it so that you get a paste of turmeric. Then you will make turmeric paper. How? By depositing turmeric paste on blotting paper or filter paper or any normal paper. You will convert it into a turmeric paper and you will let it dry. Then you will cut thin strips of yellow paper obtained and put a drop of soap solution on the strip of turmeric paper. And what will you observe? You will observe that wherever you put the soap solution drop, it will be converted into red color. Let us observe it through a picture, and you will observe red color like this, and it will indicate the presence of a base. So it is the indicator for bases usually, and it shows red color in the presence of a base. Okay.
To find the effect of acidic, basic solution on turmeric as indicator. Materials required: common salt solution, soap solution, baking soda solution, hydrochloric acid solution, washing soda solution, aerated water, shampoo solution, lime juice solution, nitric acid solution, lime water, turmeric powder, blotting paper, warm water, scissors. Method: add a spoonful of turmeric powder in a beaker containing warm water. Stir the contents well and allow it to stand so that undissolved turmeric settles down. Pour the clear solution over a blotting paper. Allow the paper to dry and cut strips 5 cm long and 1 cm wide. Dip a strip each in the soap solution, aerated water, common salt solution, shampoo solution, baking soda solution, lemon juice solution, hydrochloric acid solution, nitric acid solution, washing soda solution, and lime water. You notice the yellow color of the strip changes to brown or reddish brown in the solutions of soap, baking soda, washing soda, shampoo solution, and lime water. These solutions are basic in nature. The yellow color of the strip will not change in case of aerated water, common salt solution, lemon juice, hydrochloric acid, and nitric acid. These solutions may be neutral or acid. Note: turmeric as an indicator identifies basic solutions only. Its color does not change in acidic or neutral solutions.
We have our friend Bujo and he is telling you something that now he understands why turmeric stain on his white shirt is turned to red color when it is washed with soap. Why? Because the soap solution is basic in nature and turmeric is an indicator for base, and whenever turmeric is in contact with any base it will show it will show red color. It will be converted into red color. Okay children, so this was all about turmeric as an indicator. So let us now move ahead with the next natural indicator, which is China rose, and this China rose is also known as good health. And let us conduct an activity that will help you understand how China rose petals help you identify a substance as acid or a base. So what you are going to do is you will collect some China rose petals, you will place them in a beaker. Now you will add some warm water to it and you will let the mixture stand for some time and till the water becomes colored. Okay, water will acquire color and use this colored water as an indicator. You will use this colored water as an indicator. What you are going to do is you will take these solutions, say lemon juice, orange juice, vinegar, milk of magnesia, baking soda, lime water, sugar and common salt, and you will test their effect on China rose solution. Okay. Now you will record the observation and you will observe that in acidic solution the color changed into dark pink, whereas the basic solution turned green in color. Okay children, so what is the color change that this China rose indicator shows? China rose indicator turns acidic solution to dark pink color, whereas it changes the basic solution into green color. Okay children?
To find the effect of acidic or basic solution on the China rose solution as indicator. Materials required: common salt solution, soap solution, baking soda solution, hydrochloric acid solution, washing soda solution, aerated water, shampoo solution, lime juice solution, nitric acid solution, lime water, boiled water, sieve, China rose petals, dropper. Method: take a fistful of China rose petals in a bowl. Soak the petals in the boiling water for half an hour. On cooling, crush the petals with hand and then filter the mixture. You get pink-colored clear solution which can be used as an indicator. Take 1 cc of China rose solution in a test tube and to it add a few drops of soap solution. Shake the contents. You notice that color of the solution changes to green. Similarly, repeat the activity with shampoo solution, baking soda solution, washing soda solution, lime water solution, aerated water, lemon juice solution, hydrochloric acid solution, nitric acid solution, common salt solution. You notice that pink color of China rose solution changes to green color in case of solutions of soap, shampoo, baking soda, washing soda and lime water. These solutions are basic in nature. You notice that pink color of China rose solution changes to deep pink color in case of aerated water, lemon juice, hydrochloric acid and nitric acid. These solutions are acidic in character. You notice that pink color of China rose solution does not change in case of common salt solution. This solution is neutral in nature.
So children, we have our friends Paheli and Bujo with us. Bujo is having a query. Let us see what is his query. He is asking that he is not getting the same result when he is using solid baking soda on dry litmus paper, and he is confused why is it so. So Paheli is giving a suggestion that make a solution of baking soda and then try. So children, in order to change the color on the dry litmus paper, it requires a medium for the reaction to occur. So when you put solid baking soda on it, there will be no change in the color. So what Bujo can do, Bujo can make a solution of baking soda and try putting a few drops on it. And in doing so, what he is doing, he is bringing in the ions which are present in the liquid medium. That is, we are getting the desired medium in order for the litmus paper to show the change in color. So it is essential that you have your solution in liquid medium. Okay, children? Either you can make the solution of baking soda, or you can use litmus solution. Okay, you can use the solution of litmus. Okay, so let us now move ahead with our discussion, and we have to conduct an activity over here. What you can do is you have to collect few dilute chemicals like hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, then ammonium hydroxide and calcium hydroxide. And calcium hydroxide is lime water. This is not same as lemon juice. This is a solution of calcium hydroxide. Okay children, so calcium hydroxide is lime water. Now what you have to do is you have to test all the three indicators that we have studied up till now and observe what is the color change that you see. And you can make a table like this, write the name of the acids or the bases that you have taken, like the base which we have taken is sodium hydroxide. This is the chemical symbol of sodium hydroxide. This is what? This is sodium hydroxide. Now what you have to do is you have to test on litmus paper, turmeric paper and China rose solution, and you will observe that if we are testing the solution of acid like dilute hydrochloric acid, what will be the change? When you will bring the blue litmus paper, it will be changed into red litmus, or if you will bring red litmus, there will be no change in the color. Why? Because acids can change blue litmus to red in color, but there will be no change in the presence of red litmus. Then on turmeric, in case of acid, there will be no change in color, whereas if you test some base like sodium hydroxide, you will observe that its color will change to red in color. Then if you test it on China rose, you will observe in case of acid you will obtain dark pink color, and in case of bases you will get a green color. In this way, you can learn the color changes with all the three indicators in a much simpler way, and you will remember it for a longer duration of time, because while you are doing an activity, you tend to learn things in a better way. Okay children, so let us now move ahead, and Paheli has a query again. Let us see what is this query. Coffee is brown in color and it is bitter in taste, and you know that bitter taste is for bases. Bases are bitter in taste. Okay children, but is it an acid or is it a base? You can test it using a litmus solution. Okay children, or a litmus paper. And you don't have to give this answer without any test, and when you will conduct this test, you will find that coffee is actually, in spite of being bitter, it is acidic in nature, and it will turn blue litmus into red color. Why? Because coffee is mildly acidic in nature. And I hope that you would have understood the concept of indicators really well, and you would have learned the color change which is observed in all the three indicators. And what are the three indicators that we have studied? We have studied about litmus, then we studied about turmeric, and finally we have discussed about China rose petals. It is slightly red in color, the solution of China rose petals, okay? And what were the color changes? In case of acids, blue litmus is converted into red color, and red litmus does not change its color, that is, there is no change in color. And if we take bases, bases turn red litmus to blue color, whereas the bases, if we test the bases with blue litmus, there will be no change in color. Then in case of turmeric, we have studied in acids there is no change in color, whereas in bases it is converted into red color. For China rose petal solution, we have studied that in case of acids, the color is changed into dark pink, whereas in case of bases, the color changes, it is changed into green color. So I hope that you would have understood all about all the three indicators. Let us now move towards the definition of acid rain, and the rain that has become acidic because of carbon dioxide, sulfur dioxide and nitrogen dioxide. And from where do we get these gases? These are the air pollutants. We get them as pollutants from air. When these gases dissolve in the water droplets, we get carbonic acid. H2CO3 is the formula for carbonic acid, and this is obtained when this gas dissolves in water droplets. Then when sulfur dioxide is dissolved in water, we get sulfuric acid, H2SO4, this is sulfuric acid. Then we have nitric acid, which is HNO3, and it is obtained when the gas nitrogen dioxide dissolves in water. And this acid rain can cause damage to the buildings and historical monuments, and you might have heard about the decaying marble of Taj Mahal, and it is due to the acid rain caused by the there are lot of industries in Agra where Taj Mahal is located, and this causes acid rain and thereby corrodes the marble of Taj Mahal. Of marble of Taj Mahal and various other monuments, and this acid rain is also very harmful for aquatic plants and animals, and also the animals that live on the land, and it also disturbs the pH level of the soil. So this acid rain is very harmful. We can control it by controlling the pollution levels.